Greetings and welcome to the graphics class. Question number 10, isometric projections. A square slab of 50 mm side and 25 mm thickness is surmounted centrally by a sphere of diameter 40 mm. Draw the isometric projection and isometric view of the combined solid. This is a sphere. As you know, if you take any view of this particular sphere, whether it is front view, top view or side view, you will get a circle. So, in isometric view or projection, whatever it may be, again if you try, you will get a circle as the isometric view or projection of the sphere. Consider a sphere is resting on a particular surface. If it is resting on a surface and if you are keeping it like this, say this is the actual position of an isometric view or isometric projection. You are keeping it like this. Then initially it was like this. This is the actual situation. When it is isometric projection, you are keeping it in isometric axis. You can see that the contact point between the sphere and whatever be the surface, that is actually going inside. You are getting a feeling that the sphere alone is getting enlarged. The sphere alone is getting enlarged. Once again, I will show you. If it is kept like this, you will get the actual dimensions of the sphere. If I am doing like this, the contact point is actually going inside and the solid is getting enlarged in the isometric projection or view. That is what we are going to say about the theory of isometric projection. About the theory behind this isometric view or isometric projection can be shown like this. This is simple expression given for isometric view and isometric sphere. Consider this as the isometric view or isometric projection of the sphere. The most important thing is the radius, how the radius modifies finally. So this is known as isoradius, the radius of the sphere or the radius of the isometric view or isometric projection can be considered to be Ri. If it is isometric projection of a sphere, there you can see this radius will be radius of this isoradius will be equal to R itself, that is the original radius of the sphere, where R is the original radius or actual radius. As we know, for all other objects or all other say lines or whatever it may be, when you are going to isometric projection, the dimensions are getting reduced. But for sphere, you are having the actual radius itself. That is the importance of isometric projection of a sphere. I think it is clear to you. For normal isometric projection, all the dimensions are reduced by 82%. That is what we have seen initially. But here, in isometric projection of a sphere, the Ri, that is the radius, is equal to R, that is the actual radius of the sphere itself. This is the isometric projection. Now, if it is isometric view, what will happen? Isometric view of a sphere. When it is isometric view of a sphere, Ri is equal to 1.225 times that of R. 1.225 times that of R, where R is the actual radius. where R is the actual radius. So here in isometric, normally what is happening in isometric view for all other solids, you are having actual dimensions. But when it is sphere, you are getting the radius as 1.225 times that of the actual radius. It is getting increased. When it is isometric projection, it is the actual dimension, and when it is isometric view, it is 1.225 times that of R. That is the peculiarity of sphere. When this is applied to sphere, if you consider a hemisphere also, the same theory is applicable. The same theory is applicable to hemisphere also. We will do problems related to hemisphere later. In the question, the square slab is having a base edge of 50 mm and height 25 mm, or height or thickness, it is 25 mm. But in the case of sphere, the radius is 20 or the diameter is given as 40. Before going to the simple position, we have to draw the isometric scale, since we have to draw the isometric projection. In this particular problem, you have to draw the isometric projection and isometric view. First we will start with isometric projection, then we will move to isometric view. So how to draw the isometric scale? As we know, you have to draw AB as having a dimension which is greater than the largest dimension given in the problem. Okay, here the largest dimension is only 50, so you can have more than 50, it can be 100 or 150, whatever you want you can draw. Then from A, the inclination is 15 degree, and from B it is 45. So this part is C, A, B and C. Now we can take the dimensions from here. Say 50 can be taken, then 25 can be taken, the diameter, the radius 20 can be taken. Whatever you want, you can take as the dimensions, and you can have the parallel lines. Then you will have the dimensions along AC. Now we will move to draw the simple position. How to draw the simple position? The simple position also drawn with the dimensions from isometric projection. Isometric scale. So how to draw the simple position? Initially, you can have the XY line. Then you can draw the square slab with 50 mm sides. After this, you can have the thickness as 25. I think the thickness will be something more if you compare the dimensions. That also you can utilize. Okay. Above this, there will be a circle or sphere. So the sphere can be shown in the front view as a circle. So radius is 40. So from here you can take 20. From the center, okay, it is centrally mounted. So from center to this, it is 20. So using 20 as a radius, the radius can be taken from the isometric scale. All the dimensions are taken from isometric scale. Based on that, you are going to complete the sphere as a circle in the front view. Similar circle will be here in the top view also. So this may be the center. So you can have a 40 mm diameter circle or 25 mm radius circle will be there inside this square. Okay, so the sphere is resting centrally on top of the square slab. Now we will draw the isometric projection. So you can have the horizontal line. You are having the isometric axis which are inclined at 30 degree to the horizontal line, because the isometric axis are mutually inclined at 120 degree. Now you can have the square slab. It is very simple to draw the square slab. You can simply take one side of the square slab. Already you have drawn this simple position based on this isometric scale. So all dimensions you can take from this this particular figure itself. So you can take the square side from here. So you can measure it so that you can mark it here. So this dimension you are using here. From here you are drawing a parallel line to the other isometric axis and you are marking it here. So this is the next point. From there you are having another line which is parallel to this. Okay. So you got the bottom portion of the square slab. Now you know this is the length of the, or this is the thickness of the square slab, that you can take and you can use that dimension for drawing these lines. Okay. Now I think it is clear to you. You got a square slab. So we can have the diagonal to find out the midpoint. Okay. So this may be the midpoint. So from the midpoint, anyway, it will be along this line itself. Okay, along this line itself. So from here, you have to take this radius. This radius is actually 20 mm according to isometric scale. So that this particular dimension you can measure. This center to this contact point you can measure from here. The same dimension you can use from this midpoint. Say I am marking this as M. This is the midpoint. So from the midpoint you are taking the same dimension. So that may come, sometimes it may come above or below this one. Assume that it is coming above this. Okay. So this can be taken as the center of the circle. Center of the circle which we have to draw. So the next step is for drawing an isometric isometric projection of a sphere. The iso radius Ri is equal to R. That is the principle which we have studied. So Ri is equal to R. That means what should be this R? This R should be actual radius. Actual radius which is equal to 20 mm itself. 20 mm itself. Not, the dimension is not taken from the isometric scale. It is the actual 20 mm. So in your compass, you take 20 mm from the scale itself, from your scale, not isometric scale, from your scale itself, you take 20 mm. So C as center and the actual 20 as diameter, you draw the circle. Look here. When you are taking the actual 20, you can find out that it should definitely go beyond M. It should definitely go beyond M. This circle should go definitely beyond or below M. That is the peculiarity of isometric projection of a sphere, which is resting on top of any surface, whether it is square slab, pentagon, whatever it may be. It will go below this particular say midpoint. That is the peculiarity. So what are the things we have drawn? We have started with isometric scale. Using isometric scale, we have drawn simple positions. Using this particular dimensions in the simple position, we have drawn the square slab. Then using that dimension itself, this distance again we have taken for CM. So I am marking this as M and this is C. So or this can be C1 and M1. So CM is equal to C1 M1. That also you have to remember. So this distance you are taking. So then you found C, taking C as center, C2 then 20 mm as radius, you have drawn the circle. The actual 20 as radius, you have drawn this circle. So that is the isometric projection of the sphere. Now we will find out what are the visible edges. Or visibility we will check. For checking visibility, all the outer edges are visible. The circle is on top of the square slab, so definitely it should be visible. Definitely it should be visible. So the complete circle is visible. Now the top surface of the square slab, these portions are visible because some portions are actually hidden by the sphere. Those things we want mark as visible. Now this edge is nearer to the observer, which is visible. I think now it is clear to you. We have started with isometric scale. Using scale we have drawn the symbol position. Using the symbol position we have gone for the isometric view. And in the isometric view of the sphere we have taken Ri, that is the radius. I will mark this radius Ri here, then it will be more clear to you. So this is Ri, which is equal to R itself, which is equal to R itself. You can see that this R, this is the distance from C to the contact point that we can find out. Now we can practice this. Next we are going to draw the isometric view. Finally, the answer will look like the same as isometric projection and isometric view. Only thing is about the dimensions. When you are going for isometric projections, you are starting with isometric scale. Here there is no isometric scale. You are using actual dimensions for the square slab, the base edge, thickness and radius of the sphere. All are having the actual dimensions. Okay, you must be careful. You are drawing with actual dimensions in symbol position. There is no change in that. So you are completing the symbol position. After drawing the symbol position, you are taking the dimensions from symbol position and drawing the square slab in this isometric view. You are using isometric axis. Using the isometric axis, you have completed the square slab. The dimensions are, again I am saying, it is actual dimensions. As we know, in isometric view, we are using actual dimensions. There is no change in that. For the square slab, you can complete the square slab with actual dimensions. After that, you are going to draw the this particular circle for the sphere. How to draw that? There is a small change. See, just like the isometric projection, you are having this point M, that is the midpoint of the diagonal. Okay, midpoint of the diagonal. From there, you are using, say, C1 M1, that is the radius of this particular sphere. Radius of the sphere, the actual radius of the sphere. I am marking it as capital R, which is the actual radius of the sphere that you are using here. Okay, then you found C, point C you are getting. After getting point C, you are using the iso radius for drawing the isometric view. What is iso radius? Ri is equal to 1.225 times that of R. 1.225 times that of R, which is the iso radius. When you are using the iso radius, again you can see that the circle is going below this diagonal. Circle is going beyond that diagonal. We are expecting it up to Cm, but it is going beyond that. Okay, so now it is very clear that again the sphere is with a larger dimensions compared to the dimensions which you are drawing now. Okay. So in isometric view, what we are doing, again I am going to conclude that there is no isometric scale. Without isometric scale, using actual dimensions, you are drawing the front view and top view of the solid, combined solid. Then you are going to draw the simple isometric view of the square slab. With usual procedure for isometric view, you are using actual dimensions alone. Then you are finding the position of C with actual dimensions only. There is no change in that. After getting C, then only you are using Ri. Ri is equal to 1.225 times that of the radius, which is the circle, which is this particular circle. I think it is clear to you. We can practice this.